Unit 5, Day 2, Correlation and Line of Best Fit. So the learning goal for today's lesson is to understand how to describe the correlation of a graph. So what words can you say about what you see on a graph? And then also I want to teach you guys how to draw a line of best fit on a graph. So definitions first. So a scatter plot is a specific type of graph, and basically what this graph does is it shows the relationship between two sets of points. So this is an example of a scatter plot. And you can see that it shows a relationship between the average daily temperature and the visitors. So right now, before I've taught you guys anything, you could probably say a few things about this graph. You could say that, you know what, I noticed that as the average daily temperature increases, so does the number of people that attend the beach. For example, the highest amount of people at the beach is 600. And that point occurs at a very warm temperature. So we're going to learn some mathematical terminology to actually describe what we just talked about. But for now, just know the definition of a scatter plot. The term correlation refers to how we can describe the patterns or trends that we see on the scatter plot. So there are 3 different types of correlation that you can talk about when you're asked to describe the patterns on a graph. So the first thing you could say is you could say this graph has a positive correlation. And all that means is that the overall trend or the pattern that the points on the graph follow is an upward trend, meaning all the points as you read the graph from left to right go in the upward direction. Okay, now in terms of the items you are comparing, so maybe this was age and weight. A positive correlation means that these 2 items are both increasing at the same time. So as your age increases, so does your weight. Okay, so that's a positive correlation. So definitely know how to pick out what a positive correlation is. So if I give you 3 graphs, all with a different trend happening in them, could you circle the one that shows a positive correlation? You would just look for the one whose points go up and to the right. A negative correlation is the opposite. This is a type of correlation where the points go down and to the right. So as you read the graph from left to right, the points go down and to the right. Okay? So as one quantity increases, the other decreases. Okay, so an example of a negative correlation would be graphing the amount of snow for a given temperature, right? As the temperature increases, so as it gets warmer out, the amount of snow decreases because it would melt at higher temperatures. So again, if you're looking for a negative correlation, you'd look for a graph whose points go down and to the right. The last type of correlation that you could talk about is no correlation. So it's just a scatter plot where there's no pattern. So it really doesn't look like they're following a trend. They're not going up and to the right, they're not going down to the right. They're just kind of all scattered about. Okay, so we call that no correlation. An example of a set of data that would have no correlation or no relationship between the 2 items would be if we graphed the number of people in your family versus how you did on your math test. So if you have 2 people in your family, there's no connection between what your grade's going to be. The number of people in your family has nothing to do with how well you do on a math test. Okay, so another way that you can talk about what you see in a graph is by talking about if the correlation is strong or weak. A graph that has a strong correlation means that the points on the graph all fall into a nice line, but also the points are very close together. Whereas a weak correlation is, there's still a correlation, so they still fall in a line, but it's weak, so the points are not super close together. So here's the difference. You can see that in the strong correlation, it absolutely forms a nice line, a linear trend going down and to the right, so a negative correlation, but it's strong because all the points are very close together. Okay, in this one, it still shows positive correlation because it's going up and to the right, but it's a weak positive correlation because the points are a little bit more spaced out than they are in here. Alrighty, the next thing you guys need to be able to do is you need to be able to take a scatter plot and add in a line of best fit. So this blue line here is a line of best fit, and basically what it does is it helps you to identify the trends in the data a little bit easier, right? So if you just have a bunch of points, sometimes it's hard to see what the trend is. But if you always had a line as well, you can just base the trend off of what you see the line doing. Okay? So you guys have to know how to draw a line of best fit if I give you a scatter plot. So here are 3 points that help you draw a line of best fit. First, when you're drawing your line of best fit, make sure you actually make it go through as many points as possible. It's not going to go through all of them because it has to be a straight line, but try and make it go through as many as you can. So this one that I've drawn, obviously it can't go through all of them because it has to be a straight line, but it does kind of cross this one and this one. These are close, and these ones are also close. So I'm going through as many points as possible. Now, the second point you need to try and follow is try and make an equal number of points on each side of the line. So the ones that you can't draw the line through, try and have an equal number of the leftover points on each side of the line. And it's not always going to be perfect. Like as you can see here, the one I've drawn, I have 1, 2 on the right hand side and 3 on the left hand side. So it's not perfect, but it's really, really close. Basically, I just don't want you drawing a line of best fit way up here. Okay? Try and get it in the middle of all the points. Okay, and finally the points should be spread out along the line, not clumped on one end of the line, which I have here, right? The points are spread out from one end to the other. Let's do an example. So, number 1, several math students were surveyed to see how their time spent on social media affects their grades. The results are given in the table below. We surveyed 10 students. We asked them how many hours they spend on social media every day, and then we recorded how they did on their math test. And we want to see if there's a connection. Maybe we're going to see that the kids who spent more time on social media didn't do as well. Okay, let's see if there's a connection. So let's draw a scatter plot to show the spread of the data. So the time is our x value and our grade is the dependent value. Alright, so I have my scatter plot all ready to go. Now I'm going to graph the points. So my x coordinate is the middle column, the y coordinate is my final column. So my first point is 2 and 82. My second point is 4 and 64, 0 and 84, 3 and 70, 2 and 74, 2 and 76, 1 and 85, 3 and 73, 1 and 94, and 2 and 90. Alright, so we've drawn a scatter plot. Describe any trends evident in the data. So to describe trends, we can talk about the correlation. Is it positive, negative, or no correlation? And is it a strong or weak correlation? So when I look at this, I see a slight negative correlation, right? It goes down to the right. And I would say it's a weak correlation, right? Because we have a few points that are kind of spread out, right? They're not all perfectly tight together. So I would say weak, negative correlation. Okay, now let's draw in the line of best fit. So for this, I need to make sure it goes through as many points as possible. And then there's as close to an even number of points on either side of the line. Okay, so I went through almost 3 points, and I have 3 on one side and 4 on the other side. Okay, and it's important that when you're drawing your line of best fit, you extend it through the entire graph. So I started my line of best fit here, and I ended it way at the end. Okay, never cut it short. Okay, the last thing you guys need to know is the 2 different types of predictions that you can make on a line of best fit. So obviously you can figure out exact data for the points that you have on the graph. For example, over here, if I asked you, what percent did a kid get on the test who spent 4 hours on social media? Well, we actually have a point for that, right? Here's the kid who spent 4 hours, and there's his point. What did he get on the test? He got a 64%, right? He was this guy right here. I have a point for that. But what if I asked you, okay, what if a kid spent 3.5 hours? There's nobody in here who spent 3.5 hours. So I just have to make a guess, right? I'd find, okay, here's 3.5 hours on the x-axis. So let's go up to our line of best fit, okay? Make an imaginary point. That's probably what they would get on the test, and that's about a 62. So I could make a guess using my line of best fit, okay? Now, if I was to make a prediction using the line of best fit like I just did, and that prediction was within the data that I already had. So my data starts at this point here, right? So I'll just draw a nice line there. That's where all my data starts. And here's my last point, so that's where all my data ends. If I make a prediction within those two green lines, it's called interpolation. It's inside the set of data. If I was asked on a test to make a prediction outside of those boundaries, so for example, what percent would a kid get on the test if they spent 5 hours on social media, right? That's over here. So I would do the same thing, okay, make my imaginary point. It's about, a 55%. That prediction, this point that I was predicting, was outside of my green lines. So it's outside of the set of data that I already have. So that's called exterpolation. And here's the exact definition. So again, we have our set of data that stretches from here to here. So those are the boundaries. So if I asked you to make a prediction about something inside those two boundaries, so somewhere in here, that would be interpolation. But if I asked you to make a prediction on something outside of those two boundaries, so either here or here, that's exterpolation. So if I said that this graph represented the temperature in Fahrenheit and number of people at the beach, and I said predict how many people would be at the beach if the temperature was 30 degrees. So here's 30 degrees on the x-axis. So I go up to my line of best fit. As soon as I hit it, I put a point there, and I draw a straight line to see how many people would be at the beach. So it looks like there'd be about 75 people at the beach. That would be the guess that I would make, the prediction that I would make. That's interpolation because it's a guess within the two boundaries. But if I said, guess how many people would be at the beach if the temperature was 60 degrees Fahrenheit outside. So here's 60 degrees Fahrenheit. I'd go up to my line of best fit, put my imaginary point, go across to my y-axis. Looks like there'd be about 125 people at the beach if it was 60 degrees Fahrenheit outside. So because this point was outside of those first boundaries, that prediction is called extrapolation. So know the difference between interpolation and extrapolation.